All right, guys, here we are. We're picking back up on transformations, just like we talked about yesterday. Transformations is already stuff that we've been doing all year, right? The rules do not change, just the functions, okay? So we talked about for the square root function, it should be your a on the outside, square root of b times x minus c plus your d, right? Okay, your d and your a are going to affect your y. Your C and your B are going to affect your X. That's why they're called horizontal and vertical. Make sense? Mm-hmm. All right. So yesterday we talked about just generally what's happening and how things are moving around. Today I want to take a look at it also from a table point of view. Okay. So you should have a calculator where you also can kind of graph and follow along. So I'm not going to be doing as much graphing up here. I'm going to be talking about how does it affect our table, right? What's happening with the table? Does that make sense? All right. So we're on E and F. And if you look here at E and F, what transformation variable do we have? It's our C. Our C and our X's are what? Liars. So even though it looks like a -3, it's actually a +3. And on F, even though it looks like a +2, it's actually a -2. Okay. So that's what we're looking at. Because our C equals 3, that means that it's a horizontal translation, right? Because it's a C. C is horizontal. It's a horizontal translation, which means that we're going 3 units to the right. Okay. Again, we have our C. So that's a horizontal translation. And we're going to go 2 units to the left. Okay. So yesterday, we also talked about our parent function table, right? Our parent function table for all of our functions are, well, for the square root function is 0, 1, 4, 9, 0, 1, 2, 3. Agreed? Right. Yes. All right. So because I am shifting right, looking at my parent function, which values are changing? I'm shifting right. So it has to be your X's, because your X's go left and right, right? Does that make sense? So my X's are changing. To each one of my X's, I'm going to have to add 3 in order for it to shift to the right. Does that make sense? So my new X values are 0 plus 3 is 3. 1 plus 3 is 4. 4 plus 3 is 9 plus 3 is 12. These are my new starting points. Does that make sense? But did my Y values change? No, my Y values are still 1, 2, and 3. That's what's happening graphically. Does that make sense? I'm taking this graph and I'm fully shifting it to the right. Okay, so I can describe what's happening. So now my domain, what is my domain? Where do my X's start? 3. So X's are greater than or equal to 3. What is my range?
0.
It's Y is greater than or equal to 0. Where's my intercept?
3, 0.
3, 0. Remember, your intercepts are where your X and Y equal 0, right? Now, do I have, this is an X intercept. Do I have a Y intercept? No, because what did I literally just do? I added 3. I shifted away from the Y-axis. Does that make sense? I made that shift away from the Y-axis. Yeah?
Whenever Y is 0, that will be.
You have 2 intercepts. You either have you have X and Y intercepts, right? 2 types of intercepts. So when Y equals 0, that is your X intercept. When X equals 0, that is your Y intercept. Remember? All right. So how does that feel? Was that terrible? Okay. So let's do it again. So this time I know that my parent function values are 0, 1, 4, 9, and they're changing how? I'm subtracting 2 because I need to do what? To the left. So it's going to become X minus 2. So now what am I working with? -2, -1,
Sorry, why did we choose 0, 1, 4, 9?
So yesterday we talked about our parent function. And our parent function values for our square root are the smallest perfect squares, which are 0, 1, 4, and 9. So we're at 2 and we're at 7. Okay. Did my y values of my parent function change? No. So they're still 0, 1, 2, and 3. So now I've shifted to the left. Make sense?
Yeah.
Yeah. All right. Now, this is where it gets a little tricky. I can do everything else here, just like I did. So what's my domain? Perfect. What's my range? 0. And what is it intercept I can tell from the table? -2, 0, right? We can tell that one from the table. However, we can't tell our y-intercept from the table. Okay, but we can find our y-intercept. When you're looking for your y-intercept, that means you're looking for when x equals 0. So if I plug 0 into this, square root of 0 plus 2 just equals what? It would be what? But it would be the square root of +2.
Oh.
Do we see that?
Yeah.
Okay, to find your y-intercept, you let x equal 0. That's how you do it algebraically. Agreed? You remember doing that in the beginning? When you're looking for your x-intercept, you let y equal 0. When you're looking for your y-intercept, you let x equal 0. So if we let x equal 0, we end up with square root of 2. So that means our y-intercept is at 0, comma, square root of 2. Because this graph, let's look at it graphically. Glad you asked. So let's look at it from a graph. So I'm going to graph the parent function. So this is my parent function sitting right here. La, 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 right? I'm going to type this in, and based on what we know, this should cause this graph to do what? Shift to the right. So when I shift to the right, we're going to do second square root x minus 3, hit graph, and it shifted to the right. I'm nowhere near the y-axis. Does that make sense? Yeah. Okay. Now, when I graph the other way, second square root x plus 2, I'm shifting to the left. So I'm not moving away from the y-axis. I'm just moving to a different direction of it. So that's why this one has an x-intercept and a y-intercept.
So every time it's like, it doesn't already reach the y-intercept and then move to the right, you just kind of goes around the y-intercept.
Yes, but you also can prove it mathematically. If you plugged in 0 here, what would you end up with? And can you take the square root of a negative? No. So that tells you right there that you do not have a y-intercept, right? Do we see the difference and how the translations affect it? Okay, cool. I love the questions. All right. Was it terrible finding the y-intercept without a calculator? Absolutely not. Because is the calculator going to tell you square root of 2, or is it going to tell you an approximate value? It's going to tell you an approximate value. It's not going to tell you your y-intercept is at 0, comma, square root of 2. It's going to tell you your y-intercept is at 0, comma, point, dot, 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 something, right? Okay, questions, comments, concerns, moving from a table. We're good? Yeah? All right, so this is our C. Now we're going to talk about our B. Okay? Your B variable is with your X being, looks like it's being multiplied. So B equals 5 here. Oh, whoa, pen. My pen got a little weird. Got a little happy. Okay, B equals 5. And then B equals what here? -1/2, right? Okay, so when we look at our B, absolute value of our B is greater than 1. What did we say that meant on our transformation rules? If our B is greater, did you get the second paper out the box?
Is it a horizontal?
It's gonna be a horizontal, you need the paper out the box. There's a paper today. Okay, it's gonna be a horizontal compression.
Wait, so we don't change it to negative?
Why would it be negative?
I thought X is always, so you always change.
That is for adding and subtracting. This is not adding and subtracting. All right, it's a horizontal compression by, and it's not just 5, it's by 1/5. Okay? Because if I'm compressing, I'm cutting something down. Does that make sense? Just like when we did our Y's, it compressed and it was by 1/4. This one is going to be, what's happening here? It's a reflection first off. Why is it a reflection? It's negative, but it's over the what axis? Look at it's over the Y axis. Your B is going to reflect over your Y axis. Reflection over Y axis. And this time, instead of a compression, it's a stretch. It's a horizontal stretch by.
Why is it a compression of, or is it not,
It's a compression because for your B variable, when the absolute value is greater than 1, it's going to be a compression. I'm cutting down on my X group. Okay, when it's less than 1, yeah, so let me go back to our transformation rules. So you see right here where we wrote that if the absolute value of B is greater than 1, then it's a horizontal compression.
Oh, it's like the opposite.
It's the opposite, exactly. Okay. When something is being yes, sure. When something is being compressed, that's a fraction, right? When something's being stretched, I am multiplying it. So that's a good way to think about it. Okay. So because I'm being compressed, it's on my desk. Since I am being compressed by 1/5, that means to all of my X values of my parent function, I am dividing them by 5, or I'm multiplying them by 1/5. Does that make sense? So your parent function values, you're taking your X's and you're dividing them by 5. So remember we had 0. Well, 0 divided by 5 is going to be 0. 1 divided by 5 is going to be 4 divided by 5 is going to be 9 divided by 5 is going to be 9/5.
We don't have to like, do that.
Fractions are our friends. Okay, did our Y's change? No, we're still at 0, 1, 2, and 3. That's how a compression is affecting your values. Okay, a horizontal compression. So our domain is what? Still greater than or equal to 0. Our range is still, and our intercepts is still at 0, 0, because we didn't go left, right, up, or down. Okay, on this one, it's going to be a reflection over the Y-axis and a horizontal stretch by 2. So what that means to my X values of my parent function is that it's being multiplied by a -2, because I got to reflect and I have to stretch. So it's going to be multiplied by a -2. So -2 times 0 is 0. -2 times 1 is, -2 times 4 is, -2 times 9 is. Did we change our Y values? No. So they're still 0, 1, 2, and 3. Yeah, we did yesterday. Yesterday we focused on the Y transformations, and today we're doing the X transformation. All right. So everything is still the same because I did not move away from the origin. Oh, sorry, my X has changed because of the reflection. My X values are doing what? They're decreasing instead of increasing. And that's because of the reflection. Does that make sense? All right. So we're going to look at the graph. Is that cool? So if you have your calculator, you can follow along. We're gonna open the graphs. I'm gonna go to y equals. I'm gonna keep the parent function, but I'm gonna delete out the other two. So we're gonna graph the square root of 5x. And we're gonna see what that looks like. So I'm gonna hit graph. There's my parent function. And then there's my transformation. Okay. Now we're gonna graph the square root of negative, what was it? 1/2? Was it a half? Okay.
Yeah.
I was like, I couldn't remember what I wrote. And notice that it reflected and it's a little bit lower than our parent function. I put square root of negative 1/2 x. Got it? All right. So that's, and was our domain and range correct for all of them? Yes. All right. Easy enough? All right. So far we've been looking at everything in pieces, A, B, C, D separately, right? Are they going to always be in pieces? No, they're not. Okay. So I is an example of them coming all together. So coming all together, I have all variables represented. When it's written like this, we have to make sure that the first thing we do is factor. We have to factor underneath our square root. Okay. That's because this is not our C because it's not fully factored. If you go back to how it says it has to be written, it says B times X minus C, right? Does that look like this? No. So we have to make it look like that. So I'm going to factor out my leading coefficient, which is 2. Do we see that? The leading coefficient here is 2. So we're actually working with y equals 3 square root of 2 parentheses x plus 1. I don't know why I made that so long. Minus 4.
You can't combine them.
Why did you put it in such a distance?
They're not both underneath the square root. Did you say why am I socially distancing? Because I made my radical too long. All right, so we're going to go through and label everything we have. We know that A equals what? 3. So A equals 3, which is a what? Vertical stretch. So we have a vertical stretch by 3. Yes? Our B equals 2. So with B equaling 2, what does that mean? A horizontal compression.
Oh, yeah.
It's the opposite. Our C equals X's are liars. -1. Which means we're going to go to the left. And our D equals what?
-4.
Which means that our function is going to do what?
Go down 4.
Go down 4. Do we get it? Do we see how all of it comes together and you can still describe without actually graphing?
Yeah.
So I know that this function is going to vertically stretch by 3. It's going to compress by 2. It's going to go 1 to the left and going to go 4 down. Easy enough? Yeah? All right, we're going to graph and then describe its attributes. So let's all graph it to see if we are, how smart and accurate we are. Because we're super smart. I'm going to leave the parent function because everything is based off of that. So we have 3 square root 2x plus 1 close parentheses minus 4. So notice how I made sure I got outside of my need to insert. Notice how I make sure I mark my minus outside of it. Why did it jump over there? I don't know. Yes. And let's see. So our paired function comes in first. Bam. And then did it do everything we said it was going to do? It did.
I don't know what I did. Mine's going like the other way.
Double check
Oh, no.
what you wrote. So it should have been 3 square root 2 parenthesis x plus 1, and make sure your minus 4 is outside of your radical.
Oh,
Okay. All right. So what's our domain?
you're-
-1. Your domain comes from your C. Do we see that? So your domain's either going to be less than or greater than your C value. So our C value is -1. So, and it's going to the right. So X is greater than or equal to -1. Your range is coming from your D value, right?
So it's negative.
So Y is greater than or equal to -4.
is that the right?
That's our range. Okay, our intercepts. So when we look at this, I'm going to click on the table. When we look at this, we can see that for our 0, it's giving us a decimal, right? For our y-intercept. And that's because it's giving us an exact value, well, an approximate value. For our y-intercept, we can actually find that by plugging in our own numbers. And what number do I plug in to find the y-intercept? 0 for x. So if I let x equal 0, that's going to give me my y-intercept. Does that make sense?
3 times 4.
Yeah. So the exact value would be 3 times square root of 2 minus 4. So we would know that if we wanted to be like super perfect, it would be exact value, 3 square root of 2 minus 4. That is literally your y-intercept. Does that make sense? If not, you can tell me.
No. Yeah.
Does it make sense? And that's because if I plug 0 in for x, that's all I can do, right? That's going to give me my exact value. Your y-intercept is a little different. Your y-intercept means that you have to let y equal 0, which means that you're setting this whole thing equal to 0. So that means I'm taking this and setting it completely equal to 0. And you have to solve for x. So in order to solve for x, we got to add the 4, divide the 3, take the square. I'm not going to make you do that, but that's what you would do in order to solve for your x-intercept, the exact value of it, okay? On the calculator, let's go back to our handy-dandy calculator, though. I'm going to show you how to find the approximate value. It works best if you only have one graph, so I'm going to delete my parent function out, and I'm going to go back to the graph. You just hit second, trace, and you see where it says 0? That's where you're going. Okay. When it says left bound, that just means it wants you to go below. It wants your y's to be negative. So it wants your y to be negative. As soon as your y turns negative, you hit enter. Then it says right bound. That means you want your y to be positive. You hit enter, and it's going to tell you your approximate value is at negative 0.1111111. Okay. But you can get the same result by doing the math. Okay. I'm going to show the math on the calculator page. So what would I need to do to get x by itself? Well, the first thing I would need to do is add 4, right? After I add 4, then what would I need to do? Divide by 3. Are you still with me? Okay. After I divide by 3, then what would I need to do? Take the square, right? To get out of a square root, you have to take the square. Okay. Once I take the square, then I'm going to have to do what? Minus the 2. And then after I minus the 2, what am I gonna have to do? Divide by 2, and what do we still end up with? Did we still end up with what the calculator said? Yes. Okay, you have the skills to find these things and get these pieces on your own, okay? You're totally capable. All right. I know our class is coming to an end, but the last thing I wanted to go over with you is the cube root. This is just a problem that you would do on your own. Cube root function. Cube root function is the inverse of the cube function. Its domain and range are all real numbers. That's because it goes forever to the left and forever to the right. It has nothing that stops it. Now, if I want to find the max and min, do you think it's going to change? No, I'm still going to analyze the graph, see where the values lie. Does that make sense? If I want to know where it's increasing and decreasing, it's going to same thing. Are my transformation rules going to change because of this function? No, my transformation rules are going to still be the same. Your A is going to tell you what to do. Your B is going to tell you what to do. Your C and D, everything is going to work the same. Okay, that is the conclusion. This is our last function of algebra 2 that we have to learn. Cube root is it. Okay. All right. So practice, just all it's asking you is to describe the transformation. What variable do you have? Your A, your B, your C, your D, and what does it do to the function? Got it? All right.
Now,